Length of the tangent. Welcome, everyone. Before we dive into today's new topic, let's take a quick moment to recap what we've already covered. In our previous lessons, we established a very important rule. If you have a point located anywhere outside a circle, you can draw exactly two tangent lines that touch that circle. Now, building on that foundation, today we are going to narrow our focus. In this subsection, we are going to move beyond just drawing the lines and start defining and understanding the specific concept known as the length of the tangent. By the end of this session, you'll know exactly how to identify and measure this distance. Understanding the concept. Now that we've recalled from our previous slide that exactly two tangents can be drawn from an external point, let's look closer at what is actually happening when that line meets the circle. When we draw a tangent from an external point, which we will call point P, to a circle, notice that the line does not cut through or enter the interior of the circle at all. Instead, it just grazes the edge, touching the circle at exactly one single point. This very specific, unique point where the line and the circle meet is a crucial concept in geometry, and we refer to it as the point of contact. Keep this term in mind, because in the next slide, we will see what happens when we identify two such points at once. The point of contact. Now that we understand what a single tangent and its point of contact are, let's expand our view. As we mentioned in our first slide, if you start from that same external point, which we've labeled as point P, you can actually draw exactly two tangents to the circle. Because these two lines approach the circle from slightly different angles, they won't touch the circle at the same spot. Instead, they will touch the circle at two distinct, separate points. To keep our geometry organized, let's give these two specific locations names. We will denote the first point as T sub 1 and the second point as T sub 2. It is very important to remember that both of these points, T sub 1 and T sub 2, are what we formally call the points of contact. In the next slide, we are going to look at how we measure the distance between point P and these specific points to define the actual length of the tangent. Defining the length of the tangent. Now let's get precise about what we actually mean when we use the term length of the tangent. It is very important not to get confused here. When we talk about length, we aren't referring to the entire infinite line that we discussed in the previous slides. Instead, we are focusing on a specific, finite piece of that line. Specifically, we are looking at the line segment that starts exactly at our external point, P, and ends precisely at the point of contact that we just identified. To make this clearer, let's look at the two possible paths. If we look at the first point of contact, which we labeled as T sub 1, the segment stretching from point P to point T sub 1 is denoted as PT sub 1. Similarly, if we look at the second point of contact, T sub 2, the segment from point P to point T sub 2 is denoted as PT sub 2. Ultimately, when a problem asks you for the length of the tangent, they are asking for the numerical value of the distance between the external point P and the point of contact, whether that is T sub 1 or T sub 2. As we will see in the next slide, breaking this down into these specific steps is the key to solving geometry problems accurately. Step-by-step breakdown of the geometry. Now that we have defined what the point of contact and the tangent segments are, let's put it all together. To help you visualize exactly how to find the length of a tangent, I want you to follow these 5 logical steps. First, you need to identify the external point. Start by locating a point, which we will use to call P, that lies anywhere outside the boundary of your circle. Second, draw the tangent line. From that point P, draw a straight line that extends toward the circle, making sure it just barely touches the edge without ever entering the interior. Third, mark the point of contact. As we discussed in the previous slides, there is one specific, unique spot where the line meets the circle. You need to identify this exact point and label it as T sub 1. Fourth, isolate the segment. This is a crucial step. Instead of looking at the entire infinite line, I want you to focus only on the finite portion of the line that begins at our external point P and ends exactly at the point of contact, T sub 1. Finally, measure the length. The numerical distance of this specific segment, which we denote as pt sub 1, is what we officially call the length of the tangent. If you can follow these steps, you'll be able to apply this concept to more complex problems, like the real-world example of the tethered cable that we are about to look at next. Real-world example, the tethered cable. Now that we have established the formal geometric definitions and the step-by-step process for identifying a tangent, let's move away from abstract diagrams and look at a real-world scenario to see how this concept applies in practice. Imagine you are standing in a large warehouse and you see a massive, circular pillar in the middle of the room. Now, picture a cable that is tied to a metal hook on the wall. This cable is pulled so tight that it stretches across the room and just barely brushes against the side of that circular pillar before being anchored down. To help us connect this to the geometry we just discussed, let's perform a step-by-step analysis of this scene. First, look at the hook on the wall. In our mathematical model, this hook represents our external point, which we call point P. Second, the large circular pillar itself represents our circle. Third, the tight, stretched cable represents our tangent line. Notice how it doesn't cut through the pillar, but stays on the outside, just like the definition we saw in the previous slides. Fourth, identify that exact, tiny spot where the cable makes contact with the surface of the pillar. This specific spot is what we call the point of contact, and we will label it as T1. Finally, if we were to measure the actual length of the cable starting from the hook at point P and ending exactly where it touches the pillar at point T1, that measurement is what we refer to as the length of the tangent, or the segment PT1. By visualizing it this way, it becomes much clearer that the length isn't the whole cable, but just the specific segment from the external point to the point of contact. Now, let's summarize the key takeaways from everything we've learned so far. Key takeaways. All right, let's bring everything together. We have walked through the definitions and even looked at a real-world example with the tethered cable, so now, let's review our key takeaways to ensure your foundation is solid. First, remember the point of contact. This is that one, unique, special point where the tangent line just barely grazes the edge of the circle without ever entering its interior. Next, we have the tangent segment. As we discussed in our step-by-step breakdown, we aren't looking at the infinite line, but specifically the line segment that connects our external point, point P, directly to that point of contact. This leads us to our main topic, the length of the tangent. This is simply the numerical distance between the external point P and the point of contact, which we've labeled as T. Finally, don't forget the concept of dual tangents. As we established right at the beginning of this lesson, from a single external point P, you can actually form two distinct tangent segments, which we denote as P, T sub 1, and P, T sub 2. Keep these definitions clear in your mind, because in our next slide, we are going to look at some common pitfalls where students often get tripped up. Common mistakes to avoid. First, mistake number 1, confusing the tangent length with the distance to the center. When you are looking at a diagram, beginners often mistakenly identify the distance from the external point P to the center of the circle, which we call point O, that is, the segment PO, as the length of the tangent. Please remember the correction. The length of the tangent is the distance to the edge of the circle, specifically to the point of contact, which we called point T, so PT is your tangent length, whereas PO is simply the distance from the point to the center. Second, mistake number 2, considering the tangent as an infinite line. It is easy to forget that a line, by definition, goes on forever. Some students might think the length refers to the entire infinite line passing through points P and T. However, in geometry, when we use the term length of the tangent, we are specifically referring to the finite measurable segment, PT. Finally, mistake number 3, misidentifying the point of contact. You might be tempted to assume that any point where a line meets the circle could be a point of contact. But remember, the point of contact is only that one specific, unique point where the tangent line just touches the circle. If a line passes through the circle at two different points, it is no longer a tangent. It becomes what we call a secant line. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. As you begin solving more complex geometry problems, it is very easy to fall into certain traps. Let's look at 3 specific mistakes to avoid. Keep these distinctions in mind, and you will find much more success in your upcoming practice problems.